Hey, Nathan here. Welcome back to a new series that will cover flat paddles. And flat paddles is a game implementation that we're going to use, and we're going to use the PGL2D library. That's the alpha build. And flat paddles is just a pawn clone, a simple pawn clone. All it's going to do is it's going to have a player control paddle on the left, enemy control paddle on the right, and a ball that randomly chooses a direction during when it serves. And at the top left, it's going to have your score, the player's score. At the top right, it's going to have the enemy's score. And on the top middle, it's going to have the time that you have been playing. And it's going to use the PGL2D's input map to move up and move down. And that's the only input that's going to be allowed. So this is going to be a very quick game and a very quick series. So this is the introduction to the series, and the first thing I like to do is to just discuss how the series will be laid out. We'll be grouping a bunch of content together in folders, and we will be separating a lot of the code to interfaces and enums and very short files. And one thing that I received comments about on the previous series, which is the PGL2D Alpha series, is that I released a video for that series. My plan was, at the start, was to have a tutorial per file. And for those of you that have been programming for a while and use the single responsibility principle and like to break apart as much of your code as possible to separate things, you know that sometimes interfaces or files can be extremely short sometimes. Especially interfaces that might only have 1 to 5 properties. In that case, some of those videos that are released were 3 minutes or even down to 1 minute. And I've changed my workflow a little bit for this series, and I will mention that in a separate video. So just keep in mind that some of the files we make here are going to be extremely short. Okay. The structure, we're going to have a folder for our entities. And that's going to have our ball, our enemy paddle, our player paddle, our interfaces for the paddle to determine both player and enemy paddles will be using that interface. And we'll have a paddle control that will be an enum that will let us know in code if it's a player controlled paddle or a computer controlled paddle. And then we will have a participant, which will be the paddle. You are the participant for the player paddle. The computer is the participant for the computer's paddle. So the participant is kind of the person controlling, the entity that's controlling it. You are the participant for your paddle. The computer is the participant for their paddle. And then we will have a folder for our game screen. It's just going to have one screen in this series and no other screens. We're also going to have content. We're going to have a texture, a PNG file for our ball, and we're going to have a PNG file for our paddle. We will also have a sprite font file. And I'm using a Open Sans font for this. It's a font that you can get from Google Fonts, and it's open source. You just have to provide a license text file when you use it. It's using let me open that up. It's using the Apache license, so you just have to provide that, and any kind of changes you make to that, you need to add the reference to that. So I'm using Open Sans for my game font. So that's pretty much the whole series in a overview of what's going to be contained. We're going to have a few classes to handle our ball of what we're hitting, our paddles, our participant, the game screen, and what our content is. Alright, now let's get started with the actual coding. The first thing we're going to do is work on the structure and actually create our project. So let's go ahead and, I'm using a GitHub repository for this, so this is going to be a little bit different than what you're used to. You'll just go to new project here in the start page. I need to go to new project here, which will create a new solution. Alright, so create a new solution, and it's going to be a monogame project. It's going to be a monogame Windows project. And I'm going to call this Flat Paddles Tutorial. Click OK. And then I'm going to double click that and open that solution, and there we go. So let's work on the structure for a bit. Alright, so I'm going to create two folders, Entities and Screen. So right click the project and go to Add New Folder. Entities, and right click your project and go to Add New Folder. Screens. Okay, I am going to provide the PGL2D DLL as a reference that you can add. For those of you that do not care of how this is created, you can just straight up use this DLL. For those that want to know how to create this, I have the previous series covers that in detail. Now, this is using a newer .NET version of what our Flat Paddles tutorial defaults to. So let's right click our project and go to Properties. And let's make this a little smaller. This defaults to .NET Framework 4. Let's change this to .NET Framework 4.5.2. If for some reason you do need to target .NET Framework 4, you can download the source code for PGL2D and change that target framework to .NET Framework 4. But they have to be the same for it to work right. Okay. Go ahead and close that. Now that we got this targeting the same framework as PGL2D, let's right-click References. Actually, let me go back to here. Let me copy this location. Let's right-click References in Visual Studio and hit Add Reference. And we're going to browse. Now I'm going to paste that location into the path at the top. Now I'm going to double-click PGL2D.dll. Alright, that is checked, and then we hit OK. So now we click that. So it's looking at this specific path, D tutorial series, yada yada yada, PGL2D.dll. It's set to copy local to true, so that is what we want. Okay, now let's go ahead and make this smaller, and let's save our project and go to Build, Rebuild Solution. Everything is good. If you did not change the .NET Framework, if it's still at 4, and you try to build your project, you would see this message. The primary reference PGL2D cannot be resolved because it was built against the .NET Framework version 4.5.2 framework. This is a higher version than the currently targeted framework, .NET Framework 4. Now, if you target .NET Framework 4.6.1 on your game and go to Build, Rebuild, it'll be fine. So you have to use at minimum what the PGL2D library is. If, again, for whatever reason, you need to target this framework version, .NET 4.0, you can load up the source code for PGL2D. It is in my GitHub repository. It is free. It's open source. Just download the source code. Change that target to .NET Framework 4, and you'll be good to go. So I'm going to set this back to 4.5.2. I like to keep things the same across everything. I don't like to mix framework versions. All right. So build and rebuild, and we're back in business because we do not have that error message, and that is done. Now, if we go back to that folder, if we go and look at that debug folder, that has all the DLLs we need to run our game, and including PGL2D. So we know it's working. All right, so let's get started with the first file, which is going to be the paddle control. That's going to be an enum. So go in your Solution Explorer and right-click Entities and go to Add Class. And we're going to call this paddle control. Paddle control. I'm going to make this very small. And instead of a class, it's going to be a public enum. Public enum paddle control. It's going to have two values, player, computer. All right, save this file. So what this is going to do is it's going to tell us in the code that this paddle is being controlled by the player and this paddle is being controlled by the computer. You can do this however way you want. You can have a Boolean value that just says, hey, this is computer controlled, true or false. It really doesn't matter which way you do this. So you can use a Boolean value if you prefer that. So that is the public enum paddle control to indicate that a paddle is either player controlled or computer controlled. All right, now let's load up the iPaddle interface. So right-click the Entities folder in your Solution Explorer and go to Add Class. And at the top here, select Interface. And we're going to set this up to be called iPaddle. iPaddle. It's going to be public interface. Public interface iPaddle. And I'm going to just rename the file because I deleted the dot instead on accident. Okay. So iPaddle, public interface iPaddle. That's just going to have one property, paddle control, what we just created before, paddle control, get. So sometimes your interfaces will be extremely short. In this case, only one property. But that's going to guarantee that any paddle we create that uses this interface is going to have a paddle control. All right. Now let's look at the participant. A participant needs a reference to a paddle, but we didn't create the paddle class yet, but we created the interface. So let's create a new entity file. So right-click the Entities folder and go to Add Class. And this is going to be called Participant. All right, I'm going to make this small. So this is going to be a public class participant. So this is going to have a property for public iPaddle paddle, get, and private set. All right, so like I said in the introduction, a participant is the entity that's controlling the paddle. For the player paddle, the participant is the user playing the game. For the enemy paddle, the participant is the computer. So the participant is a game object that is handling the paddle, which is another game object. So that is why we have a participant file here. Now the participant gets points. The paddle does not get points. Public. uint. We're not going to have negative points. We're not going to go in the negative. If your game, you want to do that, just change that to a regular int. Points. Get and private set. And it's going to have one method, public void score. Whenever we score, we get awarded points. Awarded points. So we just add points plus equals awarded points. So whenever we score, we get more points. All right, so now let's create the constructor. Public participant, open parentheses. We're going to tell the participant we are controlling this paddle. So we're going to set paddle is equal to paddle and points is equal to 0. So that is the participant file. Next thing we want to create is the player paddle. So let's expand our Solution Explorer, right-click Entities, and go to Add Class. We're going to call this player paddle. We're going to make the Solution Explorer small again. Public class player paddle. Now, we're going to use the PGL2D here. It's going to be a controllable game entity. So it's going to be controllable game entity, and it's going to be iPaddle. Now we need to add using PGL2D.gameObject for it to know controllable game entity. And iPaddle. So player paddle is going to be controllable. So we're going to use PGL2D and get the controllable game entity. And we also need to tell, hey, this is a paddle. It's going to use the interface for paddle. So iPaddle this class needs to implement iPaddle, which is only one property, public paddle control, get and private set. All right. At the top of the class, we're going to have two constant private fields. Private, constant, CONST, string. A controllable game entity is going to use a input map. It's going to use the PGL2D's input system. And the way that the PGL2D's input system works is you assign keyboard presses to a action name. So for a pawn clone, the only two actions we're going to have are moving up and moving down. So we're going to have those names be constant. So private constant string move up is equal to, quote, move up. Private constant string move down is equal to move down. Okay. Next, let us create the constructor. Public player paddle, open parentheses. We need to provide the input system, and at the top we need to have using PGL2D.input. So that way it knows what input system is. So input system, color, And color is using Microsoft.xna.framework so color vector 2 position float angle float max speed string texture name. And why do we need all this stuff? That is because controllable game entity needs that information. It needs the input system, the color, position, angle, max speed, and texture name. Okay. So now, input map dot new action open parentheses move up, and we're going to add keys, and we need to add using Microsoft.xna.framework.input. So input map dot new action move up keys dot up, our up arrow key. Input map dot new action move down keys dot down. Paddle control is equal to paddle control dot player. And our speed is going to be our max speed. That's the underscore M max speed, not the capital M max speed, because we want to use the parameter. Alright, so that is it for the constructor. This is going to have one method to handle input, public, override, void, handle input. Now, handle input is provided for the controllable game entity. That only provides the available keybinds, so what is currently available for us to process. If we do not have the up arrow key held, it is not included in this list. So handle input var move up is equal to available keybinds dot first or default open parentheses predicate lambda k dot action dot equals move up. So we are returning a keybind object here if it's in the list of available keybinds, our move up action. If it is not, this will become null. We need to do the same thing for move down. Var move down is equal to available keybinds dot first or default predicate k dot action dot equals parentheses move down. So we're just checking to see if our available keybinds list contains the move up action or move down action. Var can move up is equal to move up does not equal to null, and move up dot check mode. We're going to check the input mode of this keybind. If it is held, input mode dot held. So if our move up action is in this list of available keybinds, that's what this check is for, and the key that we have pressed for moving up is held, it's not a new key press, it's held, then we can move up. Var can move down, same thing, move down does not equal to null, and move down dot check mode input mode dot held. So the exact same thing we just did for can move up. If open parentheses, so two open parentheses, not can move up and not can move down. So if we cannot move up and we cannot move down, or, so after the first closing parentheses, we need to provide or. Opening closing parentheses, or can move up and can move down. So if we cannot move up and we cannot move down, or we can move both up and down, which means we have both the up and down arrow keys pressed at the same time, we are not going to move at all. If we have up press and down press at the same time, we're just going to stay put. So we're just going to tell our object to stop. And we're just going to return. Otherwise, we're going to tell our object to start moving, and we're going to change direction. And what's the direction? If we can move up, we're going to go 3.0 float times math helper dot pi over 2. So 1 pi over 2 is pointing down. 2 times pi over 2 is just pi, which is 180 degrees, so that's moving to the left. 3 times pi over 2 is pointing up. Otherwise, we are moving down. So math helper dot pi over 2, which is pointing downwards. So when we are moving, we are constantly changing our direction. If we are moving up, we are moving up. If we can move down, we are moving down. Alright, so that is it for this class. Alright, so the next thing we want to add is the ball class. So let's right click the entities folder and go to add class. And we're going to call this ball. Now this class is going to be the ball that we're going to hit, and the computer is going to try to hit it as well. So what we are going to do is set this up to whenever it is hit, it's going to speed up. Whenever it changes direction, whenever it uses vector reflection, it's going to speed up. So we need to have a value that indicates how much speed we want to increase, and we're going to call that delta speed. We also need to hold our initial speed, how fast we want the ball to go as soon as we serve. Because when the round ends and a new round begins, we serve it by having a slower speed. The next thing we want to do is the ball is only going to be responsible for checking collision. You can have the paddles check collision, but then you're going to duplicate it, or you're going to have to create a public abstract paddle class. Because we have a player paddle and we will have an enemy paddle. Because some of those, the enemy paddle is going to be controlled by the computer. The player paddle is controlled by the user's input. So I decided to put all the collision code in the ball, because the ball will also need to check the top and bottom collision as well. The top of the screen and bottom of the screen. So instead of having two different collision codes, one in the ball and one in the paddle, I just decided to put everything in the ball. So that's going to include a collision check as well. Okay. So let's get started. I'm going to add a few using statements at the top. So using system, using Microsoft.xna.framework, using pgl2d.collision using pgl2d.gameObject, and last using pgl2d.utility. Okay, so this is going to be a public class ball, and it's going to be a movable entity, and it's going to implement iCollidable, and it's going to collide with other movable entities. Okay, so the only two properties that this ball is going to have is it's going to have a Boolean value to indicate if it's out of bounds, because if it's out of bounds, we will need to give somebody a score. And it's going to have a rectangle collision point to determine the last point that it hit. So public bool out of bounds get and private set. Public rectangle collision point last collision point get and set. Okay. Now we're going to have a few private read-only fields. So at the top of the class, private read-only float initial speed. This is going to indicate how fast we want the ball to go as soon as it's served. The initial speed of the ball. Private read-only vector 2 underscore initial position. So our initial position is going to be at the center of the screen. Private read-only float delta speed. How fast we want the ball to increase in speed when it changes its direction. When it bounces, how fast do we want the ball to change its speed? How fast we want it to increase. Private random underscore random. And that's going to be read-only. Private read-only random underscore random. Alright, so let's create the constructor. Public ball. And the parameters are going to be color, vector 2, position, float angle, float speed, float max speed, float delta speed, string texture name. And we need to call base because this derives from movable entity, color, position, angle, max speed, and texture name. Alright, so underscore initial speed is equal to speed underscore initial position is equal to position underscore delta speed is equal to delta speed, and underscore random is equal to new random, and we're going to use a GUID for seeding it. As you see, if I press a down arrow key on the keyboard, I get the overloaded method where I can provide an int seed. So I'm going to use a GUID, GUID, dot new GUID, opening closing parentheses. But we need to convert that to an integer, so we need to call dot get hash code and open closing parentheses there. There are a few ways you can seed the random objects. I decided to use the GUID approach. Okay, so that is it for the properties, fields, and constructor. Now let's go ahead and create the actual methods. So the first method we want to create is setting up vector reflection. And we're going to set up vector reflection by providing the normal we want to reflect by. And we're going to use an extension method we created in the PGL2D library to reflect. So public void reflect vector to normal var reflected vector is equal to velocity dot reflect, and we need to provide the normal. Var reflected angle is equal to float, cast this as a float, math.atan2, open parentheses, reflected vector dot y, and reflected vector dot x. Alright, we need to change direction with the reflected angle, and we need to speed up by providing underscore delta speed. So if you do not want to speed up your ball, if you just want to have it at a consistent speed, you don't need to calculate the reflected angle and call change direction and speed up. You will just be updating the velocity object. Alright, the next thing we want to do is check for collision. Public bool check collision, and it's going to check a collision with other movable entities. So movable entity. So the check collision, we're going to use PGL2D for this, and it's going to check the rectangular collision, and it's going to return a normal if a collision has occurred, which is a vector to normal. If not collision dot rectangular collision, open parentheses, provide this entity out normal. So if it did not collide, we return false. If it did, we reflect by this new normal we found and return true. So that's check collision. But the ball also needs to be aware of hitting the bounds as well, the top of the screen and bottom of the screen. So public override void hit bounds last collision point is equal to collision point. Alright. If collision point is equal to rectangle collision point dot top, or collision point is equal to rectangular collision point dot bottom. So if the collision point is either top or bottom, we reflect by the normal. We do not want to reflect our ball if it's on the left or right side. Else, we want to stop our ball, and we set out of bounds is equal to true, because that is the left and the right side. If the ball is out of bounds on the left or the right, one of the paddles is going to get a score, one of the participants. So the last thing we want to do is serving the ball. When the game first starts, or every time somebody scores, we want to reserve the ball. And that will choose a random direction. It'll reset the speed and the position, and it will reset its out of bounds state. Public void serve position is equal to underscore initial position. That's why we have the initial values. Speed is equal to underscore initial speed. Var multiplier is equal to underscore random dot next odd, and this is something I created in the PGL2D library. where it'll just determine, it'll try to give a random value, and if it returns an even value, it will loop until it gets an odd number. So we want to get a random odd, and the reason is we are using pi over 4, which is 45 degrees. So that is diagonal. So if it's 0 degrees or 0 radians, it will be moving towards the right. If it's pi over 2, it'll be pointing down. Pi over 4 is half that, which means it's pointing halfway to the right and halfway downwards. So pi over 4. 1 times pi over 4 is pointing down right. 3 times pi over 4 is pointing left and down. 5 times pi over 4 is pointing left up. 7 times pi over 4 is pointing right up. And the even values are 2 times pi over 4 is pi over 2, so that's pointing straight down. We do not want that. 4 times pi over 4 is just pi, that's pointing directly to the left. We do not want that. 6 times pi over 4 is pointing upwards. We do not want that. So we do not want any even numbers, so that's why we're getting only odd. Multiplier. So var angle is equal to multiplier times math helper dot pi over 4. So then we're going to change direction, angle, and then we're going to set out of bounds is equal to false. Alright, so that is it for the ball class. Now let's go ahead and create the enemy paddle class. So expand the Solution Explorer, right-click Entities, and go to Add Class, Enemy Paddle Class. Okay. Now this is going to be a public class. Now I'm going to add a few using statements at the top here. So we're going to add using system using Microsoft.xna.framework using pgl2d.gameObject. Alright, so the enemy paddle is going to be a movable paddle, a movable entity, and it's going to implement iPaddle. Alright, so there's only one property we want to have for the enemy paddle, and it's the same thing for the player paddle, how it's controlled, public. Paddle control, get and private set. So this is going to be controlled by the computer instead of the player. Now, when we play our game, when we are controlling our paddle, we look at the ball. We change our style of play depending on the ball. If the paddle is at the bottom of the screen but the ball is at the top of the screen, we need to move our paddle up before the ball goes past our paddle in order to block it. So we reference the ball. We need to have the computer do the same thing. Private, read only, ball, underscore ball. And this is going to be a private field. Now, to give the computer a little bit of leeway and to give it a little bit of randomness, we're going to give it a tolerance value. That way it's not exactly perfect. It doesn't appear to be a computer playing it. Because we could have the computer match its position exactly. We do not want that to happen. We want to give it some variance. So we're going to give it some tolerance value on the ball's position. So private float underscore ball tolerance. So that way the positions won't match exactly. The Y positions won't match exactly. It'll be a little bit off. Alright, so let's go ahead and create the constructor. Public enemy paddle, open parentheses, color, vector 2, position, float angle, float speed, string texture name, float rotation, float scale, ball, and rectangle bounds. We're going to bind the enemy paddle. So we're going to call base constructor color, position, angle, speed, texture name, rotation, scale, and bounds. Alright, so underscore ball is equal to ball. Underscore ball tolerance is going to equal 0. And underscore ball dot content loaded plus equals and let's let it generate its own thing. So what I did there is I just hit tab, so it automatically generated a method for it. Okay. Then paddle control is equal to paddle control.computer. The computer is controlling this. Okay. So what this is going to do, our ball tolerance is going to default to 0 because we need to reference the texture. So what we did in the PGL2D game library is to assume that sometimes this might occur where in order to fully get your object working, you might need to reference a property that doesn't exist yet. We didn't load our content yet. Therefore, we cannot work fully with our object until the ball's content is loaded. Another example of this would be if you want to center your game object on the screen. You can center it using the X and Y values, but you also need to use the texture's width and height. And that is depending on the origin of your object. If your origin is at the center, you do not need to know about that. But if it's not at the center, you will need to know the texture's width and height. And the only way to get that is after the content has been loaded. So that is why this event exists. So let's go ahead and work on that method. So we're going to set underscore ball tolerance is equal to underscore ball dot texture dot width. The whole width of the ball's texture is going to be the tolerance value. Okay. So I'm going to move that under the property. Alright. So the next method we want to create is updating the entity. So that's going to be protected, override, update entity. If math.abs, if the absolute value of underscore ball dot position dot y minus position dot y is less than underscore ball tolerance, we are going to return. We do not need to update because the difference between the ball's position and our position is less than the tolerance value. So that is why we set up the tolerance. Otherwise, var angle is equal to underscore ball dot position dot y minus position dot y is greater than 0. If that is greater than 0, we're going to set the math helper dot pi over 2. Otherwise, we're going to set this to 3 times math helper dot pi over 2. So what is this doing? If the difference between the y positions is positive, remember in monogame, the coordinate system is if we're moving to the right, we're moving in the positive x direction. If we're moving down, we're moving in positive y direction. So if the difference between the two positions here are positive, it's pointing downwards. And remember what I mentioned before, pi over 2 is pointing down. 3 times pi over 2 is pointing up. So if this is negative, we want it to point up. So that is what 3 times pi over 2 is doing here. Remember, we do not need to check to see if we can move. This took care of that. If it's less than tolerance, we return, we don't move. Otherwise, we do this. Alright, so let's set speed is equal to max speed. Let's make sure it's going at the maximum speed. Let's change the direction by having the new angle we just calculated. And we'll call base.update entity and provide game time with a lowercase g at the front. Okay, so that is it for this class. That is it for the enemy paddle. The next thing we want to create is the game screen itself. So let's expand our Solution Explorer and right-click Screens and add our game screen. Alright, let's make that small. Alright, so I'm going to add a lot of using statements, and I'm just going to copy and paste, and I'm going to name them off. We need to have using system, using system.collection.generic, using system.link, using flat paddles tutorial.entities, using Microsoft.xna.framework, using Microsoft.xna.framework.graphics, using PGL2D.collision, using PGL2D.game, and last, using PGL2D.gameObject. Alright, so this is going to be a public class game screen, and it's going to derive from PGL2D.screenSystem.gameScreen. Because we named those the same, we need to list it as this. PGL2D.screenSystem.gameScreen. You can change the name of this if you want, like flat paddle screen. That way you don't have to call it this way. Okay, there will actually be no properties for this class. It's just going to be a bunch of private fields. Private ball underscore ball. Private, remember this is our game screen. This is where our game is actually going to be controlled. Read only UINT awarded points. How many points you want to award somebody when they score? Private participant underscore player underscore computer. Private text entity, and this is what we created in the PGL2D series, underscore player score underscore computer score and underscore timer. All of our text objects. Now let's create a constructor public game screen base game bool accepts input. Bool is frozen is equal to false, and bool is hidden is equal to false. Then we need to call base game accepts input is frozen is hidden. Alright, in the opening and closing curly brackets, let's just set awarded points is equal to 1. Okay. So the constructor, my thoughts are based on you, and your thoughts might differ. The constructor is just going to be responsible for getting our properties and fields in a constructed state. We further need to initialize because we need to load our content, which we should not do in a constructor, and we need to do more stuff after we loaded our content. For example, we need to change our position based off of our texture's width and height. So the only thing we can really set here is the awarded points. Otherwise, we're going to create a public override initialize. We're going to override the initialize method. And there are two methods we want to create, and we want to call in this initialize method. Initialize game entities and initialize text entities. So we initialize our game entities and initialize our text entities. Once those are done, underscore ball.serve. We serve our ball. Alright, so let's go ahead and create those methods. Public void initialize game entities underscore ball is equal to new ball. Color.white. Color.white is, this is the tint color. So color.white is what you see in an image editor is what it's going to look like in the game. Game.absolute center 0, 150. I chose that for the speed. Remember, that speed value is pixels per second, not pixels per game loop. So our angle is going to be 0, and our initial speed is going to be 150. Our maximum speed is going to be 650. What's the maximum our game can travel per second? Our delta speed, how fast we want our ball to increase when it reflects, and the texture name for our asset, ball, which we will load in later. Alright, so we're going to underscore ball.bind entity. We're going to bind the entity to the game.dimensions. Game.dimensions. So we're going to bind it to the game screen. So that's the ball. Var player paddle is equal to new player paddle. Open parentheses. Game.input system. This needs to have a reference to the input system, so we can, if we look at the player paddle, we can query the it's going to be used in the base controllable entity to get the available keybinds. So game.input system, color.white for the tint color, new vector 2. I decided to use 100, 200 for the initial position of the paddle. 0 angle. The maximum speed this can travel is 300. And the asset name is just going to be paddle. Alright. So we're going to bind this as well. Player paddle dot bind entity. We're going to bind this to a new rectangle. 0, 0, game dot dimensions dot width and game dot dimensions dot height. Now we can do it this way because the only two buttons we will allow are moving up and moving down, so we cannot move left or right. So we can bind this entity to the entire game window. Var enemy paddle is equal to new enemy paddle color dot white, and for the position, new vector 2 game dot dimensions dot right minus 100 and 300 for the Y. We're going to push that down a little bit more than the player. Float math.py. It's going to point to the left. The angle is going to point to the left. 200 for the speed, initial speed. We want to move that a little bit slower to give the player a little bit of advantage because the computer is more accurate. The asset name is going to be paddle. We also will need to provide the rotation, which is going to be the same. Mathhelper.py. The scale 1.0f. The reference to the ball underscore ball. And the bounds we want to bind the object. So game.dimensions. Okay. So that is the enemy paddle. Now those are paddle objects. We need to convert those to participants because our game is wanting participants, not paddles. So underscore player is equal to new participant, and we need to provide the player paddle in there. Underscore computer is equal to new participant enemy paddle. Alright, now those are done, but we need to add those to our game by using the entities list that's provided in our screen. Entities.add underscore ball. So we add our ball, entities.add player paddle, entities.add enemy paddle. So we add our paddle, we do not add our participants. So that is our game entities. Next we need to initialize public void initialize text entities. Alright, so let's work on initializing the text entities. So we created the method, it's empty right now, but we created a public void initialize text entities method. So let's go ahead and fill that up. So the first, we have 3 different text objects. We have the player score, which is at the top left, and that holds whenever you score against the computer that is updated. We have the computer score, which is at the top right, and it's similar to how the player score works. And then at the top center, we have the timer, how long the game has been going on for. And it's a good idea to only create a text object when things change. The way that strings work is that when you create a if you call sprite batch.drawString with a quote, it's creating a new string object. So we want to create a new string object if our score never changes from 0 to 1, if only the computer scores. We do not want to create a string object of 0 every game loop. We want to create the string object 0 first, and then use that object as we go. And that will help a little bit. But you don't want to go overboard with this. There is a point where you're doing too much pre-optimization, and you don't want to go too far overboard. Obviously, if you can break down, for example, if you have an algorithm that has 4 nested for loops, when you can obviously do that in one for loop, you want to do that. But you don't want to just go overboard with pre-optimization. You get your code done and then optimize where it needs optimizing, and be smart when you do your code. Okay, so let's get this going. So the way I've set this up is that every time we want to update the text, we adjust the text when the content is loaded and when we update text. And at that point, we will, when the text is updated, we will do certain actions. So we're only going to update the text when we score, and we're only going to update the timer when the game time updates. Now, the timer is going to be at the top center. Obviously, a few digits might be wider than other digits. 1 is going to be a very thin digit, so it's not going to take up as much pixels as 9 or 7, let's say. So every time we update text and every time we load the text, we need to reposition. The same goes for the player score and the computer score. At the top left, if we have less than 10 score, we want that digit to be on the far left side of the screen. Obviously, a score of 1 is going to be less wide. It's going to be shorter than a score of 100. That's going to be more width, so we need to adjust the positioning. This is more obvious when we look at the top right. So let's go ahead and take care of this. Underscore player score is equal to new text entity, asset name, game text, the initial string to use, underscore player dot points dot toString, and the color we want the text to be, color dot white. Okay, now like I said before, whenever we load our content, which means that content's loaded, that sprite font is loaded, we can measure our string, and that's what happens. Whenever that's done, we need to reposition our text, and whenever we update our text, we need to do the same thing. Underscore player score dot content loaded plus equals adjust player text position. Now we haven't created that yet, but that's fine. Do the same thing for text updated. Underscore player score dot text updated plus equals adjust player text position. Okay, so that's it for the player score. We need to do the same thing for the computer and timer. Now the timer, we're going to set that to, I'm just going to copy and paste this here, since it's basically the same thing, just where the computer score, the initial text is underscore computer.points.toString instead of underscore player.points.toString. And then we give it its own adjustment method to be called whenever content's loaded and the text is updated. Now the timer, we're going to set the initial text to be timespan.0. Our game has just started, it's going to be a 0 time. And it's exactly the same format we did for the player and computer. So player score is equal to new text entity. We set it for the game text font that we're using. The initial text we give it is the player's points. We need to convert that to a string. And then it's going to be a color of white. The content loaded and text updated for player score events is going to call adjust player text position. Underscore computer score equals new text entity, same sprite font or game text. It's going to be set to initial text of underscore computer.points, and we need to call .toString for that. It's going to be color.white as well. The content loaded and text updated events for computer score is going to call adjust computer text position. Underscore timer is equal to new text entity. We set it to game text as well. The default initial text it will have is a time span of 0. We need to convert that to a string, and that's going to be color.white as well. Content loaded and text updated for underscore timer. Those events will call adjust timer position. Now we have created all of our text entities. We need to add it to our list. Text entities dot add underscore player score. Text entities dot add underscore computer score. Text entities dot add underscore timer. Okay. So now let's go ahead and create those events. Private void adjust player text position. It's going to be object sender and event args. And what this will do is it will move our text underscore player score. It will move that text to the top left. New vector 2, which is going to be underscore player score dot origin dot x and player score dot origin dot y. So that's going to be at the top left of the game window. Alright, so now we need to adjust the computer's position. Private void adjust computer text position. Alright, that's going to be object sender and event args. Alright, so adjust computer text position. It's going to be underscore computer score dot move. So this is going to be at the top right. So new vector 2 game dot dimensions dot right minus underscore computer score dot origin dot x comma underscore computer score dot origin dot y. So that's at the top right of the game window. Alright, now the last one, private void adjust timer position, object sender, and event args. So this is going to adjust the timer, and we want that in the top middle. So underscore timer is equal underscore timer dot move new vector 2. So new vector 2, we have opening and closing parentheses. Let's create a new opening and closing parentheses. Game.dimensions.width minus underscore timer dot origin dot x. After the first closing parentheses divided by 2.0 f, comma, underscore timer dot origin dot y. So that will move the timer at the top middle of the screen. Alright, now let's add the update screen override. So I'm going to, overriding members, I'm going to use ReSharper to do that. Update screen, and I'm just going to go ahead and have that generated. Don't need that, that's redundant. And I'll move that to new line. Okay, so we just overrided overrode the protected override void update screen method that we have to override from the game screen PGL2D game screen class. Now that is going to override the update screen so we can actually perform our logic in our code. Underscore timer dot update text. So we update text by providing the game time dot total game time dot toString, and we need to provide the string format we want to use. So opening double quote so that's minute, single quote, colon, single quote, SS for seconds, and the double quote. So that's going to provide the format as minutes and 2 digits, so let's say 30 minutes or 31 minutes, and then a colon, and then seconds and 2 digits. 31 seconds colon, or 31 colon 24. So 31 minutes, 24 seconds. So we update that. Now, for each var entity in updatable entities, so we only have entities that can be updated. Entity.update game time. Now, I'm trying not to talk about the PGL2D library too much in this video because this should be contained, but I think in the full release, I do not want to have this being dependent on the implementation. I mean, updatable game entities, it should be controlled by the game library. Okay, so for each var entity in updatable entities, so we want to get all updatable entities of type iPaddle. We want to use that interface, and all iPaddle.ofType movable entity. So we want to get all updatable entities of type iPaddle and iMovable. Or not iMovable, but just movable entity. So all of those, which we know we only have 2, we want to check the ball.collision. So ball.checkCollision with that entity. So it only gets... See, if we get updatable entities of type movable entity, that will get the ball as well. So we need to get of type iPaddle as well. If not underscore ball dot out of bounds, if the ball is not out of bounds, we're just going to return. Otherwise, we're going to award points and serve our ball again. Okay. So let's create that award points method. That's going to be private void award points switch underscore ball dot last collision point dot get collision side. That's what I was looking for. So that will get the collision side of when the last collision point happened. Case. If it's on the left side of the screen, the computer one. If it's on the right side of the screen, the player one. So if you didn't watch my tutorial on how to bind an object, that was covered in the PGL2D library, and I also covered that in a game math video, where we're restricting our ball to a rectangle bounds. It cannot go past the game screen. If it hits the top of the screen or the bottom of the screen, it does vector reflection. If it's the left of the side of the screen, the computer scores. If it's the right side of the screen, the player scores. So in this case, rectangle collision side left. So think of the binding box, the whole game window, as a entity, and the ball as another entity. If the ball reaches the side of the game window, that considers that a collision. Like I said, if it hits the top or bottom, it will perform vector reflection. Once it hits the left side, that is a collision. So we calculate that. We hold that reference. Our last collision point is on the left side. We have reached the end of the game window on the left side. The computer has won. Underscore computer dot score. We're going to provide underscore awarded points. Underscore computer score. Whenever our score increases, we need to update our text. So we update our text with underscore computer dot points dot toString. And then we break. And then we need to do the same thing when it's a collision point on the right side, which the player will score. So awarded points and underscore player text or player score dot update text underscore player dot points dot toString and break. Okay. So we know the ball is now out of bounds, so we know for a fact that it has become out of bounds. It will not become out of bounds when it hits the top and bottom. Therefore, if it's out of bounds, it has to be on the left side or the right side. So once we know that, somebody is getting points, so we need to award the points. Then we need to serve the ball again. The last thing we need to do for this file is to override the draw screen method. Let me get rid of this redundant Microsoft DX Native Framework stuff. Okay. So, draw screen, it's just going to be very basic. For each var entity in drawable entities, entity.draw game time comma game.sprite batch for each var text entity in drawable text entities, text entity.draw game time comma game.sprite batch. Okay. So that is it for this file. So that is game screen. The last couple files, we're going to work on the actual game, which is the game1.cs file, and the program. So I'm going to rename the game1.cs file to flat paddles game. So just rename that CS file to flat paddles game, and then click yes when it asks you to. Alright. So flatpaddlesgame.cs. That is going to be a base game implementation, and that you need to add using pgl2d.game. And pretty much delete everything in the class. Every single thing in the class. And we need to override the constructor. So public flat paddles game, open parentheses, int width, int height, string content root directory, color, background color, and then we call end parentheses, colon, base, and we call base with that information. So in the constructor, let's set screen system dot add screen new game screen. Now we need to add using flat paddles tutorial dot screens. When we call new game screen, we need to provide this and true. It will accept input. Alright, so that is it for that file. Last thing we need to do is look at program. And program, that is now having a problem with our code. Now this is automatically generated, but we're using a different way of handling our game. This, we do not have a parameterless constructor, so we need to provide the width, height, the root directory, and the background color of our game. So I'm going to choose 720p for the game window, so 1280, 720. Content for the content root directory, and new color, and we need to add using Microsoft.xnet framework. And the color I decided was 0, 100, 100. And that's RGB values. 255 is 100%, 0 is 0. Alright, so that is it for program as well. Let's take a look at our content project. So open up the model game pipeline. If you can't double click this, like I'm not able to double click this, you might have to open it manually. So let me go back to my completed code here and get my content. Okay. So I'll provide this in a zip file in the description, so you don't have to worry about that. To open it manually, I have created a shortcut on my taskbar, and that goes to C Program Files x86 MS Build Monogame version 3.0 Tools Pipeline.exe. So I just click that in my taskbar, and then I have to open the project. So File, Open. Now we need to find out where it is. So let's go back to Visual Studio and look at the full path here. Click the content.mgcb and look at the full path for that. And I'm just going to copy and paste that in open here. So in the file name, I'll just paste that full path, and that should open that just fine. Okay, so like I said, I will give you the content in a zip file. So I'm just going to add existing items. So I want to add the ball. I'm not going to add the guides, actually, because I don't use the guides. I'm going to add the paddle, ball, and sprite font. So I'm going to open those three. I'm going to copy the file to the directory. I'm going to do the same thing for the other two. Alright, so those are now copied to my directory. Now, sprite font I use, let me double click that. Alright, so the sprite font I'm using is using a font called Open Sans. And that is a open source file, open source font that you could use. But it's still recommended that you use the license. And what I did is I created a license file. I copied the license file, told you to use. And at the top, I added what I changed and my copyright. So X and B can determine on how you think about it. X and B can be considered a derivative or an actual just a variation of the work. So I'm going to right click the content folder and choose add existing item. I'm going to add that text file, that Open Sans license text file. So I'm going to add that to my project. Now I'm going to set that to copy to output directory, copy always. So that is included in our final result. So that way we are covered in terms of the license agreement. Okay. So this is the license, and this is what I changed. All right. So we are good to go now. Let's go back to the content pipeline and let's save this. And we will rebuild it. 3 succeeded, 0 failed, so we are good. Now for the moment of truth, let's press F5 and see what happens. See if we need to fix any issues. So we cannot move past the top and bottom of the screen. Our timer is being updated. Vector reflection is working. The computer scored. The ball is reserved. And the computer scored again. And let me make sure vector reflection is working here. It is. Okay. Now you can change how the enemy reacts. That was kind of a... I didn't want to spend any more time on this pawn clone than I needed to. So feel free to play around with how the computer reacts. The ball will speed up the more it's hit. And it does have a maximum speed. So if we close this, we know it's working. Timer's being updated. Our player score is being updated. The computer score is being updated. Vector reflection is working on the paddle, the top and bottom of the screen. If it hits the left side of the screen, the computer scores. If it's the right side of the screen, we score. Everything's working fine. If we look at the ball, whenever it's reflected, it will change. It will speed up by a delta speed. So that's pretty much it for this series. I didn't want to spend that much time on this since it's just a very basic pawn clone. Feel free to change how the enemy is handling the positioning so it's not as jaggy or it's not as 100% accurate. I fixed that a little bit by adding a little bit of tolerance. The width and the width of the ball is its tolerance. So feel free to play around with how it's updating and see if you can make it much better. Player paddle, it only moves up and down. It will move if you're holding down the button. It will stop if you're not holding down any of the buttons, or it cannot move. Like if we're at the top of the screen and we're holding down the up button, it cannot move. We have our sprite font loaded. I'll put a link to Open Sans. You can get it from Google Fonts. And you can download the license file with that as well. And then you can adjust that for your project. So for now, let's set this to release. And let's build that. Okay. That is it for this series. I hope you enjoyed it. I hope it was interesting to use the PGL 2D library, which handles most of the stuff for us. Next series, we will cover the implementation for PGL 2D, and it will be a space shooter, the flat space shooter. And that's going to be a little bit more interesting. I'm not going to just have it where it throws monsters from the top down. I'm going to have a little bit more of a leveling structure, and it's going to be more of a actual game instead of, something we throw up here for an hour. Alright, so thanks for watching. This is another format that I'm doing. I recorded this all in one giant video. I will master this in one giant video, and then we'll go back and cut them up in parts. So stay tuned for the next video. Thanks for watching.